Hi, welcome to this video. In today's video, I'm going to do very nice integral. Set as I equal to sine of 2x multiplied by cosine of cosine x dx as x is approaching to as x from 0 to pi over 2. Okay, go ahead, pause this video if you would like to give a try to this problem. When you are come back to see the full solution. Okay, I would like to do this type of integral because it's very important to acquire integration techniques and prepare you to do advanced integrals. Okay, now let's get into the solution. So as you see here, this one equal to from 0 to pi over 2. We have sine 2x. Sine 2x is 2 times sine x multiplied by cosine x. Okay, just trigonometry formula this one. So I will have 2 sine x multiplied by cosine x multiplied by another cosine of cosine x dx. Okay, I'm just expanding this expression a little bit in order to have the idea how to deal with this integral. Okay, so if you take a look again at this expression, you see cosine x is repeated multiple times. We have first cosine x and then cosine of cosine x. So this one is giving us idea to make the substitution here into this integral. Okay, so this one is giving us idea to replace cosine x by another variable, which is called substitution. Okay, so to make this expression very simple, okay, and short. So now I'm going to put set cosine x equal to t. Okay, I'm going to differentiate this one. I will have dt equal to minus sine x dx. Okay, so that's mean dx equal to minus dt over sine x. Okay, I'm not going to replace sine x by substitution because I see another sine x in the front of this expression. That's going to be simplified. So now my expression, and another thing to notice here, we have bound from 0 to pi over 2. Now I have to change this bound in terms of t. Okay, so as you see here, we have x equal to 0. This one implies t equal to, if you replace cosine 0, it will be t is going to be 1. Okay, if you replace x by pi over 2, you will have t equal to 0. Okay, so my bounds I have from 1 to 0. Okay, and 2 times sine x cosine x will be cosine x will be replaced by t. Okay, multiplied by cosine of t because I'm replacing cosine x inside of cosine by t, multiplied by this one minus dt sine x. You see the sine x that I mentioned before now will be cancelled, now will be simplified with this one. Okay, if you previously replace sine x by the substitution, you will not able to simplify this sine x, then your integral become more challenged. Okay, so now what I'm doing here, I'm going to switch these bounds and change the minus sign to the plus sign. Now my integral become from minus 0 to 1. With this minus it become plus. Okay, so we'll have 2 sine x will be simplified, so we'll have 2 times cosine t multiplied by this t dt. Now my new integral is this one, so I'm going to take number 2 outside of this integral. I will have 2 times the integral from 0 to 1 t cosine t dt. Okay, now I see have two functions here. I have t multiplied by cosine t. Now it's more clear to apply by part as a method to solve this integral. Now let's set d du equal to cosine t and v equal to t. Why I'm putting du equal to cosine t? Because to find the original function of cosine t is easier. You go to the sine t. Okay, if it's sine t, it becomes cosine t. If cosine t becomes sine t, it's easier to find the original function. That's the reason I put du. V, because v equal to t, because when you derivate this function t, it become 1. That's the reason so that's at the end your integral will be reduced. Okay, now it will be easier to solve it. So now my I integral become 2 times. I'm taking these two out of this expression, so I will have the first integral as we see here. So my integral become on this form, so uv minus u dv. Okay, this is the general expression of by parts method. Okay, so always you are going to bring this one and then you are going to derivate. I'm going to derivate this function v. Okay, so now my integral become on this form. My integral become on this form now. So u, which is sine of t. Okay, t I'm going to leave it as is it. Okay, so now plus these two minus these two, because we have minus in this integral. So if I'm going to derivate this one, this function will become 1. Multiply this, the primitive function of cosine t. I will have sine t. Okay, sine t dt. As you know, the bounds from 0 to 1. Okay, now we were at this expression now, so I'm going to plug number 1 and 0 into this first expression, so I will have number 2 outside of this expression. So sine t, if you plug number 1 into this, sine t will be sine 1 multiply by 1 minus 0. Okay, minus 2 times. I still have this integral, so now I'm going to evaluate this integral. This is straightforward integral. Okay, so the original function of this sine t will be minus cosine t. Okay, so we'll have minus cosine t, the bound from 0 to 1 always. So this one, 2 sine 1, this one, first one, minus 2 multiplied by minus 1, I will have plus 2. Okay, plus 2 cosine t, the bound from 0 to 1. So we'll have 2. I'm going to multiply 2 out of this expression. So we have 2 multiplied by sine 1 plus this cosine 1 minus cosine 0. Okay, which is 2 sine 1 plus cosine 1 minus 1. Okay, so my integral I equal to times sine 1 plus cosine 1 minus 1. Okay, so I have done with this problem. Thank you for watching. I will see you in next video. Bye.